Our next step, according to the list we have here, would be to measure rheology. We are going to do this using a VG rheometer, which is going to allow you to measure 6 dial readings. This is a 6-speed device. We can measure plastic viscosity, yield point, and gels. Now, if you pay attention, this device has 3 speeds that I can show in this switch, and also it has a gearbox, so I can position this in such a way as to measure 6 and 300 RPM, 200, 100 RPM, and finally 6 and 3 RPM. I'm going to proceed then. I already have a sample. So what I'm going to do is fill the cap to a certain line which is indicating me that that's the proper level. And I'm going to put this in the proper position, lifting to a certain level. This has to click to a certain position like it was a bayonet device. And now all I have to do is lift this and put it in place according to a rim I have here in this bob device. Now what I'm going to do first, of course, is go 600 RPM. So I'm going to go to high speed, and I'm going to go to this particular gear. You could probably see that this is rotating pretty fast, 600 revolutions per minute. All I have to do now is to wait for the rheology to stabilize and take a reading. And I can see that that reading is 82. Now I'm going to go ahead to the low speed for this particular gear, which is 300 RPM. Wait for the rheology to stabilize. And I can see here that the reading is 43. So these two numbers are enough for me to be able to tell you 82 minus 43 will give us a plastic viscosity of 39, and 43 minus 39 is giving us a yield point of 4. So here I have plastic viscosity, yield point. Now, given the fact that we are going to be using a sophisticated model of Herschel-Bulkley, we need some more reference points. So I'm going to go ahead now and measure 200 RPM. I'm going to go to the upper gear here and go to high. So here I have 200 RPM. Wait for the dial to stabilize. And it's clear to me that the reading comes to 30. Now I can go down to 100 RPM with a switch, same gear. Wait for a few seconds for the dial to stabilize. Sometimes it requires longer time. And I believe that's a 16. Now I have to measure 6 and 3 RPM. So I'm going to switch gears, go to the middle. There we go. And high. I don't know if you can see this, but this is rotating very slowly. I'm going to imitate. And it's going to give us 6 RPM. And I can clearly see that the dial reading comes to 3. What I can do now is go to the low speed, same gear. Now this is moving very slowly. I'm going to imitate it with my hand. 3 RPM. And I can see that the dial reading comes to 2. So I have a complete set of data for rheology determinations. One thing I'm going to need now is to measure the 10 seconds gel. So what I'm going to do now is change this, go to a high speed, switch to high, and go to this particular gear. So I'm rotating that. Make sure that I break all the gels using a high or relatively high shear rate. And after moving this for maybe 2-3 minutes, I could probably take a little break and then come back. I'm going to go ahead and stop this and count 10 seconds. So what I'm going to do is stop this, start counting 10 seconds, go to the middle gear, and make sure that I started at 3 RPM and watch for the maximum deflection. There we go. And I can tell you that the dial went all the way to 4, so that would be my 10-second gel 4. The units are pounds per 100 square feet. What we are measuring with this dial is a measurement of shear stress in units of pounds per 100 square feet. Now I want to do the same, but now we are going to measure 10 minutes. Number one, I'm going to go ahead and break all the gels, rotating as fast as I can with this device, 600 RPMs, maybe for 1, 2, 3 minutes. I'm going to reset the stopwatch. And I'm going to stop measuring the time. And now I have to wait 10 minutes. So it's been 9 minutes, and I'm measuring the 10-minute gel. So in a few more seconds, I will have to go ahead and start this VG meter at the lowest velocity, which is 3 RPM. And I'm going to do that now. So I'm going to the low, rotating at 3 PM and paying attention to the maximum deflection here. And I can see that it peaked at 6. So my 10-minute gel comes to 6 dial reading, which corresponds to 6 pounds per 100 square feet. And this concludes our determination of rheological values.